Now that we know how to do stoichiometry and we can go through those steps of figuring out an unknown based on an equation, next up we want to be able to determine the limiting reactant. So what runs out that keeps us from producing more product? Let's start by looking at a real world example of what a limiting reactant is so we can understand what that means. Okay, so let's say I'm making some sandwiches. I look in my cabinet and I have 4 slices of bread. I have a brand new unopened jar of peanut butter, and I have half of a jar of jelly. Okay, when I go to start making sandwiches, what am I going to run out of first? I'm going to run out of bread. I only have 4 slices of bread. That means I can only make 2 sandwiches. I have an entire jar of peanut butter, so I've got plenty of peanut butter, especially since I only like a little tiny bit of peanut butter on my PB&Js. And I've got half of a jar of jelly. I can probably make 6 sandwiches with half of a jar of jelly, so that's plenty of jelly. What I'm going to run out of is bread. I don't have enough bread to make more sandwiches. Okay, my excess reactant in this example would be the peanut butter and jelly. So after I use up all of my bread, I'm still going to have peanut butter left over and I'm still going to have jelly left over. Okay, so that is an example of limiting reactant in the real world. You can also think about s'mores. So if you have a whole box of graham crackers and you have a brand new unopened bag of giant marshmallows and you have 1 Hershey's candy bar, how many s'mores can you make? And what are you going to run out of? Well, the first thing you're going to run out of is the chocolate bar because you have to use 4 squares of chocolate for every s'more, and you only have 1 candy bar, so you're going to run out of that first. Okay, so whatever you run out of first, that's your limiting reactant. Okay, and so that limiting reactant, it gets all used up. There's none of it left. You run out of it, and it determines how much product you can make. So that chocolate bar determines how many s'mores you can make. In my first example, my bread, that determined how many sandwiches I could make. Okay, so same idea with these chemical equations. The one that runs out first determines how much total product you can make. Okay, and then the excess reactant is the one that you still have some left over. You don't run out of it. So how do we determine the limiting reactant in an equation? Step 1, write the balanced equation. And again, sometimes I'll give you the balanced equation. Sometimes I'll give you the equation unbalanced. You have to balance it. Sometimes I'm going to give you a description of an equation. You have to write it out and then balance it. So it just kind of depends on where your starting point is for each individual problem. Then you have to calculate how much product is formed for each reactant. So you have to do the steps of stoichiometry twice, okay? Once for each reactant. Okay? Whichever one has a smaller answer, that one is your limiting reactant. That one gives you the amount of product that it is possible to make. Let's do an example. Okay, so here's your problem. 79.1 grams of zinc react with 0.9 liters of 2.5 molar HCl. Identify the limiting and excess reactants. How many liters of hydrogen are formed? Okay, so down here we have our balanced equation ready to go. Okay, so now under my equation, I'm going to write down my information that I know and identify my unknown. Okay, my unknown is hydrogen because it says how many liters of hydrogen. So that's my unknown, and I know I want the answer to be in liters. Okay, what are some of my known information? Well, I know that I have 79.1 grams of zinc, so I'm going to write that under my zinc. And I know that I have 0.9 liters of hydrochloric acid, and I know that its concentration is 2.5 molars, so that's my molarity there. Okay, so this is my known information that I have written down. Okay, I'm going to take that information we just wrote down onto another slide so I have space to do my stoichiometry because I ran out of space. Okay, all right. So now what I'm going to do is I'm going to start with one of these. I'm going to go ahead and start with zinc. And I need to go from zinc using stoichiometry to get to my liters of hydrogen. Okay, so let's start our line and start with our known. So I know I have 79.1 grams of zinc. Okay, we need to get that to moles because we always need to get to that mole to mole ratio. Okay, so if I have grams up here, I need grams of zinc down here. Looking back at my stoichiometry notes and that conversion diagram that I gave you guys, we can see that we can go from grams to moles using molar mass. Got to use the periodic table to do that. Okay, so where did this number 65.39 come from? That came from the periodic table. That's the molar mass of zinc. Okay, and there's only one zinc there. Okay, so 65.39 to 1 mole. That's going to let my grams of zinc cancel off. And now I have my 1 mole of zinc. Now I'm ready for that key stoichiometry step, the mole to mole ratio. And I see using my coefficients, I have 1 zinc to every 1 hydrogen. Okay, so 1 mole of zinc goes on the bottom so that I can cancel off 1 mole of hydrogen on top. Okay, so now I've switched to my unknown, my hydrogen. Awesome. And what do I need it in? I need it in liters. So how do I go from moles to liters? That new constant that I gave you, because this is a gas, that 22.4. So mole goes on the bottom so that they cancel off. And I'm left with liters of hydrogen, which is what I wanted. And now I multiply everything across the top. 79.1 times 1 times 1 times 22.4. Multiply across the bottom, 65.39 times 1 times 1. And then divide that top number that I got divided by the bottom number. 27.1 liters. Okay, so with that many grams of zinc, I can create this many liters of hydrogen. Now, I'm about halfway done with the problem now. Now we need to do the exact same thing, but now we need to do it for the hydrochloric acid. Okay, so my same knowns and unknowns, but now we're going to start with HCl. Okay, my known is I have 0.9 liters of HCl. Okay, now to go from liters to moles, I can use my molarity, which was also given in the problem, 2.5. Okay, so I'm going to put the liter on the bottom and the mole on top because that way my liters will cancel off. So now I'm at 2.5 moles of HCl. I'm at moles. I'm ready for that key step, that mole to mole ratio. And I see that I have 2 moles of HCl to 1 mole of hydrogen. Okay, my moles of HCl on top, moles of HCl on the bottom to cancel off. Now I'm at moles of hydrogen. So now I'm at my unknown, which is good. But I need my final answer to be liters. So I'm going to convert from moles to liters using that new gas constant, 22.4 again. Okay, moles on top. So the moles have to go on the bottom here so they can cancel off. And now I'm left with liters of hydrogen. Multiply across the top, divide by the bottom. We will get 25 liters of hydrogen. Okay? Now I need to compare the two answers that I calculated. Okay, we calculated 27.1 liters when we used the zinc. We calculated 25 liters when I used hydrochloric acid. So which one of those two is smaller? 25 is smaller. Okay, since 25 is smaller, that means that my limiting reactant is hydrochloric acid. My excess reactant is zinc because I'll still have zinc left over when I run out of the hydrochloric acid. And so that means that my product formed is the 25 liters. Since it's smaller, that's the maximum amount that I can create. Okay? All right, now it's your turn to practice. Okay, independent practice, determining the limiting reactants and how much can be created based on those limiting reactants. As always, if you need some help, schedule a meeting with me so that I can help you. You will not be able to do this until you understand stoichiometry, so hopefully you did not move on from your stoichiometry activity until you got a passing score on it.